Hey guys, this is Mr. Ciolkosz from Joliet Central, or Mr.C, as you most likely know me. What I'm doing here is I'm going to go through 80 questions, so this is 4 separate portions or example tests of the SAT No Calculator math test. So first thing we're going to notice here is that we have 25 minutes to answer 20 questions. So I'm going to try to keep the explanations to at most that amount of time for each section. With that said, feel free to pause this video at any time. I'm going to do this all in one sitting, so I'm going to go through all 80 questions right now so that you should have a comprehensive video to cover pretty much all of your questions on here. I did my best to show work in the least higher level math way possible, so going with the simplest method of solving these. So most of the math you're going to see on here is covered in our college prep levels of Algebra 1 and Geometry. And then some of the more analytic problems, so those word problems, are going to come into you guys in college prep advanced algebra. So none of this stuff is going to be stuff we've never seen before. It might sound different, but the key idea here is we're going to use our critical reasoning skills in order to determine the best and fastest method to solve a lot of these problems. So going through it here again, reminding yourself at that time, 25 minutes for 20 questions. With that said, we're going to use some test-taking strategies when we're going through this, indicating which questions are those higher level, maybe more tedious or time consuming questions, putting those off to the end and ensuring we get as many questions right as we can. Again, the use of calculators is not permitted. So going through a couple of these notes, all variables and expressions used to represent real numbers unless otherwise indicated. So with that said, we're assuming a variable is working with real numbers, so these are the standard number system we're used to working with. Basically, that means I is not involved unless they say it can be. Figures provided in this test are drawn to scale unless otherwise indicated. That's actually a nice, useful little piece there, meaning we can use some approximation skills if we're not sure where to start. All figures lie in a plane unless otherwise indicated, so we're looking at two-dimensional figures rather than three-dimensional. And assuming our domain is all real numbers unless otherwise indicated, so that there's no holes and there's no discontinuities in our graphs. For a reference here, you'll notice there's a lot of useful information on this front page. So we have pretty much everything about our standard geometric shapes, as well as our three-dimensional solids. Also, they even give us those special right triangle formulas. So if we see one of those 30, 60, 90, or 45, 45, 90 triangles, it's not something they're expecting you to memorize. You can always look back as a reference on those. Coming down here as well, some reminders about circles, whether it's the radians or degrees we're concerned with, as well as the triangle, again, knowing that those sum to 180 degrees. So as we move on here to question 1. For question 1, we have if x minus 1 over 3 is k, is equal to k, and k is equal to 3, what is the value of x? So this is a multivariate equation, but again, we're just going to substitute that 3 in and isolate or solve for x. So first step here, I have my variable on the numerator of a fraction, so I multiplied the denominator on both sides to get x minus 1 is equal to 9. Adding 1 to each side gets me x by itself. Number 2, they give you a reminder that I is equal to the square root of negative 1. What is the sum of the expression? First thing we got to do here, whenever we're summing things, those complex numbers, we're going to treat I like a variable. The only time it becomes a number we're used to seeing, an integer, is when we multiply it. But since I'm just adding, I know to treat it like a variable. So here I did 7 plus negative 8 to combine my whole numbers there, my constants, to get negative 1. So I can quickly eliminate choices C and D. Next part, 3i plus positive 9i. So I treat I like a variable, add my coefficients of 3 and 9, and arrive at 12i. Question number 3 here. Again, we see a lot of words, but reading through it, we find that Armand sent M text messages each hour for 5 hours, and Tyrone sent P text messages each hour for 4 hours. So we're trying to figure out the total number of messages sent by them on Saturday afternoon. So again, going with the order we're given, 5 and M are together, 4 and P are together, so multiplying would tell me their individual totals, and adding the two together gives me the total between the two. Part 4. This question gets down to identifying what that number 108 means in the equation. From reading, we find out that she has a set number of phones she needs to fix each week. And P is going to give me the number of phones left. So after each day, where D stands for days, I can find out that my initial or my y-intercept of this linear equation, would be 108. So 108 is the number of phones she has to fix each week. So a big concept you're going to see recur a lot throughout this is the slope and what it means in the context of a word problem. So think back to y equals mx plus b in the different synonymous words we've used to identify slope. So rate of change, how many things are happening in a given period of time, and then getting to the y-intercept there, so the different way we talk about a starting value or an initial value. Question 5. Here we are combining two expressions, or we're conclusing them together, so equivalent expressions. Key idea here, don't get scared by all the variables. So the first thing I did here was, to get rid of that subtraction in the middle, I distributed -1 to each term. So I made this a plus symbol, changed this to positive, this to negative, and this to positive. Notice also out here I highlighted which terms I'm combining. So my first term on the left was x squared y. Looking in my term on the right that I'm summing it with, I find I have another term with those same variables. Now for both of these boxed in terms, I have no coefficient. What that means is there's a 1 there. So adding 1 plus 1 gives me 2 x squared y. Just going from left to right, my next term was -3y squared. I look over here and it's in a different order, but it's still a similar term, right? It's a like term. So -3y squared plus 3y squared. Well, -3 plus 3 is 0, and if I multiply anything by 0, it goes away, or it becomes 0. Thus, these two terms cancel out. My final term on the left side is a positive 5xy squared. Looking in the right, again, the underlying term is -3xy squared. Well, 5 minus 3 is 2, so I have 2xy squared. Moving on to number 6. From reading through this problem, we're looking for the estimated increase in inches of the boy's height each year. So anytime we see each year, we're given that given time interval. We know we're looking for something continuous that's also representing our change. We're thinking how much this individual is growing. So just from what we know again about linear equations in the form of y equals mx plus b, I'm looking for a slope because it's a rate of change. So I can rather quickly identify that that is the 3 in the equation, where the initial height would be that 28.6. Question 7. This is one of those questions that's meant to look rather confusing. However, if we simplify a bit here and we focus on what we know about algebraic reasoning, this problem becomes a lot easier. So from reading through, the sum up here is they want us to get p by itself. From initial glance at this equation, I notice that p is off already. So since it's off to the side, what that implies is multiplication. So if I were to rewrite this, p would be in my numerator. Now, a quick way here, and a quick tool you'll see us use over and over again in this review, is the idea of the reciprocal. So in Algebra 1, you've all seen concepts of an equation such as 2 equals, this is something I'd write down to understand this better, 2 equals 1 over 2, or 1/2, times x. So again, the equation I'm referencing is 2 equals 1 over 2 times x. Now, there's a bunch of ways that we could solve this. One would be by dividing by 1/2 on both sides. That's a method that's more likely utilized when the calculator is present. But here, you've also learned concepts of the reciprocal. So if I wanted to get that x by itself, I'd multiply it with the reciprocal. And again, the layman terms of the reciprocal is flipping a fraction. So if I wanted to do the reciprocal, I would multiply both sides of my equation by 2 over 1, which we know is just 2. But for the sake of utilizing this tool, we're going to write it as 2 over 1, because we can write any whole number as the same number divided by 1, as well as any number for that matter, because dividing by 1 does not change the term. Noticing that, on my right side of that equation, my 1/2 and 2 over 1 cancel, or they multiply to 1, which is what we call canceling in mathematics. Thus, it's just x. On the left side, 2 over 1 times 2, well, when I do a fraction times a whole number, I multiply that whole number to the numerator, the top of the fraction. 2 times 2 is 4. My denominator is still 1. So here, in that equation, we get x is equal to 4 over 1, or just 4. Using that same concept of the reciprocal here, since p is by itself, it's like my x in that equation. So to get this entire giant fraction moved over to the left side to isolate p, I'm going to multiply by the reciprocal. So I'm going to make my numerator come down here, and my denominator come up here into the numerator. From that, we can find our answer and isolate p rather quickly. Question 8. Here we're given some information that if a over b is equal to 2, whenever it's an if statement, they're telling you to assume that's the case. This is true. We're not solving it. That's something we're just told. That's like saying x is equal to 5. What is the value of 4b over a? So first, notice in my step here, I set up a over b is equal to 2 over 1. So again, using that idea that dividing by 1 doesn't change anything. Next, I utilize the reciprocal again. If a over b is 2 over 1, then we know that b over a has to be 1 over 2. So again, flipping both sides of our equation. So now I got the b over a. I need a 4 on top. I can multiply both sides by 4. So here, that led me to 4b over a. So now I'm at that term. So now it's just about simplifying my right side. Well, 1 times 4 gave me 4, and it's still over 2. Then I noticed that, well, 4 over 2, that reduces. That turns into just 2. Moving on to question 9. What we're working with here is a system of equations. So we see our equations presented to us in our standard form. And we have what is the solution xy to the system of equations above. Now the method I used to solve all equations in here, when it was available, was elimination. If you were never taught elimination, what I would suggest is taking some time over spring break. Just go on Google or ask your local math teacher. Go on there and say, ask them, hey, can you help me out with learning how to solve by elimination? It's just a slightly faster method than direct substitution, because there, unlike you see here, since they're presented in standard form, we'd have to isolate a variable first and then substitute. And on a test like this, it's a lot about how quickly you can get to the same answer. So another method, if you're uncomfortable with, maybe asking for a couple worksheets on elimination, would just be Googling or going on YouTube and typing solving systems of equations using eliminations. So systems of equations using elimination. And there'll be some great resources there as well. So by the elimination method here, I'm trying to match my coefficients with the opposite. So I'm going to add these functions. So similar to the process of long division with polynomials, what you're going to do here is try to get your x's or your y's to match up, with one with a positive coefficient and one with a negative of the same number. So the first thing I did here was I switched my terms, because we know it doesn't matter what I add in, right? So I switched the negative x and the 2y. Next I wanted to say, okay, I'm going to match up my x's first. You could have done your y's first, but x was in front, so I went with that one. So I had 3x and a negative x. So I recognized that multiplying by 3 on the bottom would give me a negative 3x here. So distributing, my x's cancel out when I add those functions. Here, 3 times 2 is 6y. So when I added down 4y plus 6y, it gave me 10y. Similarly, 3 times negative 19 is going to give me negative 57. So negative 3 plus negative 57 gave me negative 80. Dividing both sides by 10 gave me y is equal to 8. At this point, I could actually jump to my answer. However, to get the ensured correct answer, I plugged in, and again, we could plug it into any equation. I chose this one. So I did 2 times that negative 8, so I substituted my value of y in the equation. Minus x is equal to negative 19. And solving gets me to x equals 3. Moving on to question 10. So we're presented with a function. Now, there's a couple ways to solve this. If you're real familiar with the properties of even functions, so things with exponents of 2, 4, 6, those even numbers, you can kind of shortcut this, because for any even function, g of x is equal to g of negative x. However, let's say we didn't know that definition, we didn't know that concept, we could still solve this algebraically. So here we're given that g of 4 is equal to 8, and we're trying to figure out g of negative 4. So I notice I got 2 variables. I don't know what a is, but they tell me it's a constant. That means it's just some kind of number, so I could probably figure out what it is. So what I did is I plugged in 8 for my y, or my g of x, and I plugged in 4 for x. Simplifying gave me 16. 8 plus 24 is equivalent to 8. Subtracting 24 divided by 16 tells me a is negative 1. So here what I did, I plugged in negative 1 for a, and they wanted g of negative 4, so g of negative 4 is equal to negative 1 times negative 4 squared plus 24. Through simplifying, we did end up at 8. Number 11, so again, a bit of a longer problem here. Here is the key in the wording. So we're presented with two equations, B and C, dealing with the price of beef and the price of chicken, respectively. So respectively just means in the same order we just gave you them. That's the order we're talking about. And I'm told that X is the number of weeks. So, key concept here is I figure out what I'm doing. So I have what was the price per pound of beef when it was equal to the price per pound of chicken. So the first thing I know is I see the word equal. So that means I can set these two things equal to one another. So I took each of my equations. So I started off with the concept of B equals C, and then substituted the appropriate equations. Here, so I'm combining my like terms. So I subtracted 0.25x from both sides. What that gave me is 0.15x. I then got my constants, my numbers on the other side. So I subtracted 1.75 on both sides and got 0.6. Dividing by 0.15 on both sides, arriving at x is equal to 4. The strategy here, if you're not comfortable with decimals, would be to figure out what I could multiply everything by to get whole numbers. So if I notice, each of these is dealing with money, so they have two decimal places included, because that gets up to how we round with cents. So, if I were to multiply everything by 100, that would give me 235 plus 25x is equal to 175 plus 40x. So that's another method if you don't feel comfortable with decimals. But in either case, you'll end up with x is equal to 4. So here, answering the question, they want to know about the beef. So I took my beef equation and substituted 4 in for x. Multiplying and adding, we end up at 335. Moving down to question 12. Here we have a line in the xy plane passes through the origin. So vocab term, origin. I know that's the point 0, 0. And has a slope of 1 over 7. So here, the first thing I did is I want to make sure I have the right linear equation, because it's telling me a line. Anytime I have a line, that's y equals mx plus b. It can be written in that form. So I started off with that, just plugging in what I knew. So I plugged in my slope, my m of 1 over 7. Next, I substituted my x and y. So here's my y coordinate. Here's my x coordinate. To figure out what my y-intercept would be if I couldn't figure that out from the given information. Multiplying here gave me 0, subtracting 0, still 0, so b is equal to 0. That got me here to my equation is y equals 1 over 7x. The best method I would have utilized to solve this is by plugging in each of these x values, multiplying by a 7th, and seeing which one gave me the corresponding y value. But from checking here, I get to my final answer. If I multiply 14 by 1/7, well, 14 times 1 is 14, divided by 7 gives me 2. So that would be the only correct solution here. For number 13, we're given if x is greater than 3, which of the following is equivalent? So, this is one of those questions that if you come to and you are not incredibly comfortable with, I would suggest maybe saving this one for the end. There's not a whole lot of shortcuts to this one. This is just algebra. So what I'm going to do here is walk you through it, but again, for a lot of students, this might be a question you wait till the end for. Maybe you'll find a one you can get through quickly and make up that time. So for here, the first thing I notice is I want to combine these terms, right? They're on the bottom. Because I just had a 1 on the numerator, not a whole lot I could do with that. So what I did first was get a common denominator, because that's what we need to add fractions. So what I did here was multiply the top and bottom by x plus 3. And this one, I multiply the top and bottom by x plus 2, so that's where I'm at here. From this point, I now have a common denominator of x plus 2 times x plus 3. I then added my top. Now that I had a common denominator, that's like saying what's 1/2 plus 1/2. So, adding my top, x plus x gave me 2x, 3 plus 2 gave me 5. At this point, I have a fraction divided by a fraction. Back to our concept of reciprocals. So this would be, I could multiply by the reciprocal here. So that would be flipping it over. So I have x plus 2 times x plus 3 over 2x plus 5 times just 1. So essentially, it flips my fraction over. The last step here, because I'm looking, oh, I don't see this as an answer. So what I did now was multiply out the top. So I did x times x to get x squared, 2 times x to get 2x, and then x times 3 to get 3x, and 2 times 3 to get 6. Combining my like terms of 2x and 3x gave me 5x. So we can see in our last step here, we find our correct solution. Moving on to question 14, we have if 3x minus y is equal to 12, what is the value of 8x over 2y? So, a couple of different methods for solving this here. If you're familiar with your exponent laws, that would be the best method in my mind to get this equation solved rather quickly. So the first thing I noticed is I got two variables. So I decided to solve this one for y to get both of these in terms of x. Because I noticed I got a lot of answers here that are just some number base up to an exponent. So just some different looking numbers. So I substituted that. So I plugged this equation in for y. Down here. Now, using what I know about numbers and bases and all of this great exponent stuff, I realized that 8 can be written as 2 to the third power. So 8x, or 8 to the power of x, is equivalent to 2 to the power of 3 times x. This way, I now have a common base on the top and bottom. This goes back to when you guys were in geometry for the college prep level and you did equations like x to the 5th over x to the 3rd. So in an equation like that, again, x to the 5th over x to the 3rd, I know that to simplify that, that's the same thing as saying x to the 5 minus 2. So, here, I combine my equations. Now it's 2 up to 3x, so my top, or my numerator term, does not change. However, I did have to flip the signs, or distribute a negative 1 when I brought this one up to the numerator. So that gave me negative 3x plus 12. Here, I notice my 3x is canceled, and I end up with 2 to the 12th. Alright, question 15. Here, we're given a lot of information. So the first thing I did here from reading through is I noticed what I know. I know a plus b is 8. Well, it tells me a and b are just some kind of constant terms. And I'm figuring out the two possible values for c. So upon inspection, I noticed that none of these choices have anything in common. So once I get one of the numbers through algebraic reasoning, I can pretty much jump to my answer there. But what I did was show you how to get both. So the first thing I did was I noticed this is in the form of our standard quadratic equations, right? So I can determine, okay, c is a constant. X is our variable. Because it's saying for all values of x. I mean, that's what we don't know. That's our variable in the term. So first thing I did was expand this left side. So I multiplied, 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 multiplied. That got me here to AB. Now notice those parentheses. The reason why I put them there is because we know A and B are just numbers. So whenever you have a coefficient, isolating it with parentheses visually is going to help you solve this problem. So I have AB x squared plus, our next term, 7ax, again the parentheses, plus 2bx plus 14. What I did now was combine these two terms in the middle because they are like terms, and A and B are just numbers. So if I want to combine those, since they both have a variable of x to the first power, those are my like terms. That got me to abx squared plus, in parentheses, 7a plus 2bx plus 14. And here I went down and brought this equation from the top. First thing I noticed, I got plus 14 on both sides, so I can ignore that at this point. I'm good there. Because again, saying these things are equal for all values of x means that my terms have to match up. So I look, well, in front of the x squared is 15, so I know a times b has to be 15. And here, this 7a plus 2b is going to be equal to my c. So, thinking about the factors of 15, I know that's 1 and 15, and then 3 and 5. That given information that a plus b is equal to 8 helps me to quickly get down to the fact that 3 and 5 are the only options I can use here. So to get both of my answers, I alternated which number here between 5 and 3 I determined was a. Because it doesn't say they have a is bigger or a is smaller, so they can go either way. That's where we get those two answers. So if I chose a is 5, I would plug in here and arrive at 41. If I let a be 3, plug in accordingly. Substituting, we get our c is 31. Hence my choice of D. Alright, so as you can see here, 16, 17, 18, 19, and 20 are open-ended answers. So this means show the work that you need to solve the problem and make sure you clearly indicate what your final answer is. So I'm given if t is greater than 0 and t squared minus 4 is equal to 0, what is the value of t? So first thing I did was add 4 to each side to get my t by itself. Then the opposite of squared is the square root, so I took the square root of both sides. Now, whenever you take the square root, think back to geometry. What that tells me is when I take the square root of a number, technically I'm getting both the positive and negative number. Because if I worked backwards, either one would get me to the same spot. So now I have two answers for t. So t is equal to positive or negative 2. But back to that little piece of information at the beginning, t is greater than 0. That allows me to arrive at the final answer of t is equal to 2. Moving down, here we're given a geometric type problem. So I can quickly identify what I'm solving for, but the first thing I did was label what I know. So reading through this and paying attention to order. Make sure you label your diagrams correctly. So AB was 1800, so I labeled it there. Going on through, we label accordingly. Do a quick check. Make sure you labeled everything that you know. Now, what we're also given is that AEB and CDB have the same measure. That means they're congruent. So these two angles match up. Next step here, labeling everything I can determine. These two angles here in the middle are vertical angles. So vertical angles are formed whenever two lines intersect, and we're looking at those opposite angles. So knowing they're congruent tells me something. If I have two pairs of congruent angles, what I can conclude is these triangles are similar. So that's angle-angle, or AA, similarity. From that, I can write my similarity statement. Paying attention to the order, so ensuring we have B in the same spot in both, because those are congruent. E and D in the same spot, because those are congruent. Gets me to my similarity statement here. And again, there's a lot of variations for this, but order matters. From this, I can set up my ratios. So EB over DB is equal to AE over CD. Where I got those from is I figured out what I needed to solve for. I know I needed AE because that's my X, that's my unknown variable. And then picking out the given information you know. So ensuring you're using the right ratios here. From that, we go ahead, we cross multiply, so 700 times X, 800 times 1400, divide 1400 times 800 by 700, and we'll find that X is 1600. Moving on, question 18. Again, I referenced elimination, so if you want to go back to earlier in the video or take those notes you've taken from Googling a couple examples of this. Here, I want to get X by itself. So the quickest method here is to eliminate Y, since I'm just concerned about X. If you wanted an ordered pair in XY coordinate, then it doesn't matter which one you solve for first. But for this one, since I'm just worrying about X, I want to eliminate Y. So upon inspection, I see my X's are in order and my Y's, as well as my constants at the end. So I'm going to go right into multiplying. To get rid of that 2Y, what I did was distribute a negative 2 to all of my terms. So that gave me negative 2X, negative 2Y, and a positive 18. So here, after canceling out my Y's, I have negative 2X is equal to 18, and X is equal to negative 25. Adding down, negative 1X is equal to 18 plus negative 25 gives me negative 7. Dividing by negative 1 on both sides gives me X is positive 7. Question 19. Anytime you're given a very complicated looking question, chances are it's just testing your reasoning skills and what you know about different mathematical concepts. So don't think, well, it looks scary, I need a calculator, I need to graph. If it's on the no calculator section, it can be done by hand. So in a right triangle, one angle measures X, where, knowing what we know about trig, so SOHCAHTOA, sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent, TOA, is equal to opposite over adjacent. The first step in any one of these problems is labeling what you know. So I drew here a right triangle. I called my bottom left angle X. It doesn't matter which one you call X, as long as it's not the right angle. But I can label my diagram accordingly. So from here, I labeled my O, A, and H. So to get the opposite angle, I think of drawing an arrow directly out from the angle in question, or in this case, the angle X. Drawing it out, that's my opposite. A hypotenuse is always directly across from the right angle. So here's my H, and by default, my other option is that adjacent side. From there, I know that sine is over H. So I labeled my opposite as 4 and my hypotenuse as 5. Here, we utilize the Pythagorean theorem. So to figure out what that other side might be, because I don't know if I'm going to need that information, I called this a variable, so you can call it A. So A squared plus 4 squared is equal to 5 squared. So when solving that, we find that A is 3. So my adjacent side is 3. Now, we're trying to figure out what is the cosine of 90 minus X. In any right triangle, if I take away that right angle, I know that these two angles have to add to 90. because 180 minus 90, well, still gives me 90, so they're complementary. So looking at this term, 90 minus x, I can conclude that that angle reference is here, because this and this have to add to 90. So from there, now I'm looking at the cosine of this angle. So I would rewrite my opposite adjacent hypotenuse. What I'll find is that this is now the adjacent side when referencing the opposite angle from this. So here, cosine adjacent over hypotenuse would be 4 over 5. Our last question from the first section, so again, 1 through 20 is just representing one of these tests. I have if a is equal to 5 root 2, and 2a is equal to the square root of 2x. What is the value of x? So the first step I did, I took the equation that had x, and I substituted what I know about a. Working with this, so I multiply 2 times 5, because those are constants, they're not involved in a square root there, so they're rational numbers, they're integers. So I get 10 square root of 2. Now, to get x by itself, I need to get rid of that square root. So to do so, I squared both sides. So when I squared this, my square root and my squared cancel, getting me to 2x on my left side. When you're squaring a number like this, that means I'm doing 10 root 2 times 10 root 2. Well, the numbers out front, 10 times 10 gave me 100, and square root of 2 times square root of 2 just gave me 2. Here, I would get 200 is equal to 2x. Dividing both sides by 2 gives me x is equal to 100. At this point, we have concluded the first section of this. Again, so you have 4 practice tests here, 4 methods of reviewing and preparing for the SAT no calculator math section. By working through this section, you'll be better able to succeed in the calculator section as well. Moving on to section 2. Okay, so look at number 1. We find out that this is pretty similar here to the first question one we see. So again, this is an entirely different example of a short answer section, or a no calculator section. So for here, I want to, given this 5x plus 6 is equal to 10, what I'm solving is what is the value of 10x plus 3. So the first thing I did was go ahead and solve here for x in the first equation. And I got 4 over 5. Moving on down. So I substituted that in here into that 10x plus 3. Multiplying 10 by 4/5, well, that's 10 times 4, so 40 over 5. And 40 divided by 5 gave me 8. 8 plus 3 gives me 11. Number 2, again, getting back to that concept of elimination. Now, again, there's other methods of solving this, and if you talk to your local math teacher, they would be more than happy to review substitution with you. But again, I've always found that elimination is a faster method. So I decided, okay, I'm going to cancel my y's first. The only reason I did that is because I already seen I had a positive and a negative here. Because if it wasn't, if I wanted to cancel x's, then I would have had to multiply the top by negative 3. So keeping things positive, I distributed 2 to each of my terms. So that gave me 2x plus 2y is equal to 0. Now adding down, well, 2 and 3 give me 5. 2 and negative 2 cancel, and 0 and 10 give me 10. Dividing, I got x is equal to 2. Now plugging back in, I picked the easier looking equation. So I had x plus y is equal to 0, substituted 2, subtracted, and I find y is negative 2. Number 3, again, going back to this algebraic reasoning for our linear equations. Reading through this question, we find out which of the following is the best interpretation of the number 12. Well, here, if we're looking, again, that's linear. So 12 is like our slope, or it's our per hour type chart. Now, this question, I used a bit of a shortcut here. So you could completely expand these, but what I know about exponents, I know about these, is I want to get to this first and last term, because the middle one's just going to be adding things together. So which of the following is equivalent to the expression shown above? So what I did here was check the first and last term. So if I wrote this out again, if I want to expand this first option here, I would have 3a squared plus 2b squared times 3a squared plus 2b squared. So I know my first term is doing 3a squared squared, or 3a squared times 3a squared. That gave me 9a to the 4th. And at the end, again multiplying that last term, 2b squared times 2b squared, would give me 4b to the 4th. Similarly, checking this out, if we multiply, just checking the first terms for each of these, I'm not even getting close to that 9a to the 4th. So, no matter where you start, you can quickly notice if that first term's not right, None of them are right. Moving on to question 5. So if k is greater than 0 and x equals 7 in the equation above, what is the value of k? So we're told x is just a number, so I plugged it in. So that gave me the square root of 2k squared plus 17 minus 7. And notice whenever I substitute, I always utilize parentheses. Just in case it's a negative, it reminds me to act accordingly. It's equal to 0. So the first thing I did was I added 7 to both sides. Then I squared it to get rid of my square root. So that gave me 2k squared plus 17 is equal to 49. Subtracting 17 got me here, dividing by 2 got me here. And again, taking that square root to get rid of my squared variable gave me positive or negative 4. Using back to that logic that k has to be greater than 0, I get just 4. Number 6, we have in the xy plane of block, the line L is parallel to the line K. What is the value of P? So, first thing we're recognizing here, I got parallel lines, right? So I can start using some things I know about corresponding, alternate interior, getting back to that Algebra 1 stuff with our angles. So the first thing I did here, I labeled some lengths of lines, right? Because I'm trying to figure out what P is. And if we look, that's this coordinate here. So I know the length of this is 2. If we're going from the origin to negative 5, well, that means regardless of direction, it's a length of 5. Because we always think of length in positive terms. The negatives are just giving us direction. Looking over here, I see that this is going to give me 4. Now, how I determined they were similar. So I have those vertical angles again. I know these are both right angles. So I can say that that's one angle. And again, using our concept of parallel lines, we can determine that these two angles are going to be congruent and that these two angles are congruent. So I have similarity, I have similar triangles. Noticing that, again, looking here, I see that to go to 2 to 4, well, that's double. So if I did 5 times 2, that would give me the 10 for here. This length, which is representative of P, because I'm starting from 0 and going to P. Number 7, we have x up to the power of a squared divided by x up to the power of b squared is equal to 16. Saying x is bigger than 1, and that a plus b is equal to 2. So what is the value of a minus b? Back to our exponent laws. So what I did here is I set this up as x to the a squared minus b squared. So getting this up into a single term with a single base is equal to x to the 16th. Well, if these bases are the same, then these exponents better be equal, because I'm saying they're the same thing. So I can get rid of my bases and just examine the exponents. So a squared minus b squared is equal to 16. Working backwards here, I can expand this to a plus b times a minus b is equal to 16. Then I'm told that, well, a plus b is 2, so I substitute 2 in there. Now, I divide it by both sides by 2. So I got a minus b is equal to 8. That's what I'm solving for, so I can get the choice A. Moving on to number 8 here. So, what we're trying to figure out, if the measure of an exterior angle of a regular polygon is greater than 50, what is the greatest number of sides it can have? So we're given a formula here. So I have the n is my number of sides, a is that angle we're talking about. So plug it in 50 and dividing. And well, I got a 0 at the end on both, so I can cancel those, or I'm technically factoring out a 10 from both, because both have that as a factor. Then reducing it to 1, so that gets me to 36 over 5. Now, I'm thinking about how many times 5 goes into 36. So that goes in 7 times, because 7 times 5 is 35. And I have 1/5 left over. So, or, if you want to reduce it, you get 7.2. And it's saying the greatest number of sides. So I can't round up here, because you can't make 8 from 7.2 or 7 1/5. I'm not quite there. So that tells me my biggest number of sides, my greatest number would be 7. Moving on to number 9. So I have the graph of a line in the xy plane as a slope of 2. It contains the point 1, 8. So what I did first here is figure out my equation for line 1. So I substituted my slope, my x and my y, and I solved for b. That got me my line 1 is equal to 2x plus 6. For the second line, we're given 2 points. So to write that equation, I found the slope first, got negative 1, and then picked a point, substituted, and got b again. So here's my line 1 and line 2. Now, if the two lines intersect at a point A, B, what is the value of A plus B? So, from this point on, we know that they intersect. So here, if they're intersecting at the point, it means it's equivalent. So I just picked the easier looking line. So once I solved, line 2 actually looked a bit easier to me. So I plugged in x is equal to a, because we're looking for a coordinate a, b. So x is my a, y is my b. From there, I isolated that term a plus b and found out it was 3. We have which of the following equations has a graph in the xy plane for which y is always greater than or equal to negative 1. Here, what I'm thinking of is if I plugged in 0 for x. So if I want to see when is y always greater than or equal to negative 1. Here, if I plugged in 0, well, that's negative 2. Here, negative 2. If I did this one, negative 2. But for this one, if I plugged in 0, I would find out that that would give me a positive value. So by default, there's our answer. And again, where I got the concept of plugging in zeros, I noticed none of these have a negative coefficient, or none of them have that negative out front of our parent function. So utilizing 0 would tell me one of the critical points, or potentially the vertex of that graph. Alright, bit of a longer one here. Which of the following complex numbers is equivalent to 3 minus 5i divided by 8 plus 2i? And they remind us y is equal to the square root of negative 1. So here, when we want to get an I out of the bottom or the denominator of our fraction, we multiply by the opposite. So we're switching this term out here, because what that's going to do is start getting rid of that I for me. So I multiply the top and bottom by 8 minus 2i. Expanding on the top and expanding the bottom, my denominator turned into 64 minus 4i squared. My top turned into 24 minus 6i minus 40i plus 10i squared. Now, when we move on here, so the first thing I did was I'm going to combine these middle terms. So negative 6i minus 40i. That gave me negative 46i. My top, when I substitute, I have I squared. That's just a fancy way of writing negative 1. So I did 24 plus 10 times negative 1. Well, that's 24 minus 10. That gave me 14. From here, I notice I have a common factor. These are all even numbers. So I divided each one by 2. That gave me 7 minus 23i over 34. Knowing how we break up fractions, that gave me my choice C. So here we're looking for which one of us gives us the number of favorable views, which they defined as f. So to solve for this, I need to get f by itself. So first thing I did was multiply both sides by n plus f. Here, I then distributed my r. Next, I got both of my f variables on the same side, so by subtracting. Now I notice these have f in common, so what that means is I'm able to factor it out. So that got me to my next step here. Then finally, to isolate f, I divided both sides by 1 minus r. 13, what is the sum of all values of m that satisfy 2m squared minus 16m plus 8 is equal to 0? Well, I need to get that variable, so instead of x, like we're used to, we called it m here, but it's going to be the same way. So what I utilized was the quadratic formula. You could also do this a couple different ways, but a quadratic formula, we know we're going to get that right answer every time. So from working through our quadratic, we ended up at our answer of d is equal to 8. Number 14, we have a radioactive substance decays at an annual rate of 13%. If the initial amount of the substance is 325 grams, which of the following functions models the remaining amount of the substance in grams t years later? Alright, we did this back in Algebra 1. So what I know is that I have an equation similar to this. So I called it y. Here they called it f of t, meaning a function of t. I let a be my initial number, or my initial amount, times 1 plus r. So r is the rate, up to the power of t. Now, since I'm decaying, that's like having a negative rate. We never plug in a percent, so I made it a decimal at 0.13. From here, I know 1 minus 0.13 gave me that 0.87, and my initial amount was that 325. So rapidly you can eliminate C and D, and we figure it out here to get our final answer of A. Moving on to 15, we have the expression 5x minus 2 over x plus 3 is equivalent to which of the following? From here, what we did is utilize synthetic division. So at this point, you can also utilize long division, but again, having learned synthetic, it does tend to be a bit quicker. So, you also have all seen this by this point in advanced algebra, so it's a concept you should be readily familiar with due to the timing of our curriculum. So the first thing I did here was figure out what I had to divide by. So if I assumed this was a 0, that means I'm dividing by -3. I look, I'm not missing any terms, so I just have 5 and 2, or -2 I should say. Multiply, bring my first term down, we multiply around, and I add down, knowing that my last term there is a potential remainder. So, -3 and 5, -15, add these two, we get -17, and rewriting that gave me 5 minus, because it's negative, 17 over what I divided by originally. Question 16. If the sales manager of a company awarded a total of 3,000 in bonuses to the most productive salespeople, the bonuses were awarded in amounts of 250 or 750. If at least one 250 and at least one 750 were awarded, what is one possible number of those 250s? So I set my total of 3,000 equal, and I call X my 250, the number of 250s, and Y the number of my 750s. So I said, okay, I got at least one of these ones. So I could let it equal 1. What that gave me is I now have X is equal to 9, just from plugging in, subtracting, dividing. Similarly, if you said, okay, let's say, what if there was 2 Y's or 3 Y's? You can arrive at your other answers of 3, 6, or 9. But again, they're saying, what is one possible? So solving for any one, I would always suggest using that. Well, if it's at least 1, I could just plug in 1 just to make the math a bit more easy. Here, for 17, we have in the equation above, a, b, and c are constants. If the equation is true for all values of x, what is the value of b? First thing I did was expand. So I had 6x squared plus 10x plus 9x plus 15. From combining our like terms, we have 6x squared plus 10x plus 9x plus 15. I combined. Here I see b is just that middle term. So from combining these, I find that b is 19. Alright, so in this one, getting back to our geometric reasoning, we have in the figure above, AE is parallel, that's what those two lines mean, to CD. So, as soon as I see parallel, I know I got alternate interior, corresponding, I have all these angle relationships. They're telling me everything intersects at B. What is the length of CE? So I call CE my big thing I'll have to find. And now I know this portion, B, is 8. So I really just need to find CB and add them together. So, the first thing I did here was use my vertical angles. Setting up a similarity statement, I know that 5 over 10 is equal to x over 8. Solving, I got x is 4. Well, 8 plus 4 is 12, so that total length is going to be 12. Here, if in the xy plane above, O is at the center of the circle, it's our origin. If the measure of angle AOB is pi over a radians, what is the value of A? Now remember, if you're not comfortable at radians, you can always look back on that very first page, which I didn't include in this section, but it's at the front. It will be in this when you take it. And go to degrees. But here's another way of doing it. So we're figuring out what A is. So the first thing I did was label what I know. And they're given that A is root 3 over 1. So to get to those things we know, I converted these to the unit circle. Now, we know the unit circle deals with a lot of things over 2, so I divided everything by 2. So this gave me 1 over 2 is 1/2, because that's the value of y, so that's the height here. And then the length here, well, that's my x value, so that's root 3. So that gave me an x of square root of 3 over 2 and a y of 1/2. That gets me that radius of 1. From there, I know that that corresponds, that point of A being root 3 over 2, comma 1/2, deals with an angle of 30 degrees. Going from 30 degrees back to radians, well, I do 30 So again, going from degrees back to radians, I do 30 divided by 180, which is 1 over 6, times pi. So I finally get an answer of pi over 6. So if that's my measure of degree in radians, what that would tell me is A is equal to 6. And our final question for this section, we are given two equations. And the system values A and B are constants, so they're just numbers. If the system has infinitely many solutions, what is the value of A over B? Well, infinitely many solutions, or what I call IMS, means that these things are exactly the same. So the first step here is I know that equation 1 and 2 are the same thing, they just look different. So what I did here, since I know these are the same, I know that I can make them look the same by multiplying by a scalar or a constant. So I decided, okay, well, 12 and 60, those are just numbers. I'm going to work with them first. So I know 12 times something has to give me 60. That something here, to avoid confusion, I called alpha. You can use any shape or letter you want as long as you know it's a variable. So I did 12 times alpha is equal to 60. Solving by dividing by 12, I found out that that scalar, that alpha, which you'll commonly have seen called k, is going to be just 5. Well, 2 times 5, that gave me 10, and 8 times 5 gave me 40 to figure out what my a and b in the first equation are. So figuring out that ratio, a over b, well, it's a over b, 10 over 40, which is 1/4, or that 0.25. This concludes section 2 of our review for the SAT No Calculator section. Moving on down here to section 3. For this one, we're getting back to our wording, right? So if the customer asks the painter to use a more expensive brand of paint, which of the following factors in the expression will change? So this is just wording out what we know. So again, it's just looking for that words, and we find that k is going to be that variable. So here, figuring out what each of these variables mean is going to help us determine that answer. For question 2, we have if 3r is equal to 18, what is the value of 6r plus 3? So something similar, right? So we solved for r, we plugged in, and we got our answer. So substituting that r equals 6 into our equation. We got to 3, which of the following is equal to a to the 2/3 power for all values of a. Well, this is just knowing how to go from exponential to rational or radical form here. So, radical, apologies there. So if I went back, well, the bottom thing goes on the outside and the top thing stays on the inside, so I get the d. Next one, what we're looking for here is which of the following equations are true. So we find out between the first time period is twice the number of sales between the second. From doing that idea of twice, that means 2 times. And then we know that 30 is where we started, so 2x is equal to 30. So this is just taking the words and putting it into an equation. Question 5 here, we're trying to figure out what is the value of x over 5. So the first thing I did here was multiply. So I did 5 times x plus 20. Distributing that 5 got me here. And then multiplying here got me 15x. Next, I isolated x to solve to find x is 10. So subtracting 5x, dividing both sides by 10. Then just plugging on in. So substituting that 10 for my x here. Well, 10 over 5 is 2. Question 6, we've seen a couple examples like this already, so I'm back to the world of elimination. So, not only am I solving for my coordinate at this point, but then I'm doing x minus y. So going through our elimination here, I had to multiply both the top and bottom to utilize elimination. I find out y is 6. Substituting x is 2, well then x minus y, 2 minus 6 gave me that -4. You'll notice that by this point, since a lot of these questions are similar, I'm going to move a little quicker through stuff we've already talked about in depth, just for the sake of time. For question 7, the function is defined by polynomial. Some values of x and f of x are shown in the table. Which of the following must be a factor? So, going back to what we learned in advanced algebra, if for a value of x, I have a 0 in my f of x or my y column, that implies it's divisible. So, if 4 is a 0, that means that it's divisible by the term x minus 4. So just working backwards like we did in advanced algebra. Moving on to question 8. Line y is equal to kx plus 4, and where k is a constant, so k is just a number, is graphed above. The line contains the points C, D, where C and D are not equal to 0. That means I could put them in the bottom of a fraction. That's all that term means. We could divide by them. What is the slope of the line in terms of C and D? So first I wrote my equation. D equals K times C, because that's where they're going in. C is my X, D is my Y, plus 4. To get K represents that slope, because C and D are just some numbers. So I got K by itself in terms of C and D, and I found my slope. Moving on down. So, yet again, utilizing elimination to get K by itself. From using that, we combine, we add, we isolate, and I find K is equal to what we have here. So K is equal to 12 over 5. My apologies here, this was a mistake in my handwriting. I kind of skipped, I forgot to put the division symbol here. So K should be 12 over 5. And then the 10. We have a parabola with the equation y is equal to x minus 11 squared. Intersects the line with equation y is equal to 25 at 2 points. What is the length of AB? Well, here, what we know about parabolas, right, is that I have a y-intercept somewhere down here at negative 11. My apologies, that was poorly explained. What that means is I am shifted to the right 11. Because when we're inside that grouping symbol of parentheses, we always think of our transformations from the parent function as opposites of the grouping symbol. So minus 11 really means move right 11. Now, the line y is equal to 25 is a horizontal line. So from substituting here, I could figure out what my points are, work through this, and I arrive at my final answer. So then I can go and say, okay, each of these are 5 units. Again, from just solving our equation here. So again, what we did here to solve this was I plugged in. So I plugged in 25 on this side. Over here I have my equation. Because since it's intersecting there, that means at some value of x, I'm going to get that number. So, working through, we can arrive at x is equal to 16. Then, plugging in, I find my distances, and I can determine that the total length there is 10. Moving on to 11. So this is kind of a tricky one. It's just kind of figuring out what we can say is true. So there's a lot of various methods here. So for a question like this, I would suggest trying to use your own method. So labeling what you know is true. So I knew that x plus y is equal to u plus w. Figuring out what, the different things about 180 might be. So knowing the vertical angles, knowing what things need to sum to. So if all 3 of these terms are going to give me 180, if all 3 of these are giving me 180. This is a question that would be best explained in person. So I would suggest talking to your local math teacher through this one. So, what I did here for question 12 is I first recognized that, well, we know about synthetic division. If these are factors, I have zeros at 2 and negative 4. So, if I have zeros there, I know my vertex for a quadratic equation is right in the middle. So the value of x directly between those two. So finding the middle of these numbers, I did 2 plus negative 4 and divided in half. That got me negative 1. So I know my vertex, because they're asking me for the vertex with the coordinates c, comma, d, is at the point negative 1, comma, d. Plugging in there, I simplified, I found that d is equal to negative 9a. Moving on to question 13, we are given our equation, and we're saying is true for all values of x not equal to 2a, where a is a constant. So again, that whole concept there is just saying, well, we're not going to divide by 0. So, division, what that gets me into here, division implies if it's divisible by it, right, so I can take this on out, and I multiply it over. So because I can go from here to here, I'm simplifying, so it's like working backwards. So I'm going to distribute that to everything. A little expansion here I get here, so multiplying each of these terms out. This is again another one of those problems you might want to come back to at the end when you're actually taking the test, because it's a lot of algebra. Again, simplifying on through, I'll finally, after canceling out some terms, working through some algebra, I'll see here that, well, These are my two terms. I don't know. That's my a. So if I divide on through, look at a is negative 3. So, trying to figure out these solutions. To save myself some time with the mental math, first thing I noticed that 3, 12, and 6 are all divisible by 3. So I simplified them. Then I'm trying to solve a quadratic. So I go right into quadratic formula. From doing so, we'll finally get down to our answer of negative 2 plus or minus the square root of 2. So at this point, if you are not 100% comfortable with quadratic formula, that's something I would again talk to your local math teacher, YouTube, Google. Find yourself some example problems with that. Now, question 15 again. For the sake of time, we're not going to read through this one piece by piece, but here's the strategy. Whenever you're asked the question, based on the equation above, which of the following must be true? It's all about eliminating what you can say is not true. So look for the not trues. Don't necessarily try to logic your way through everything that has to be true. For 16, this is going to be a much more algebraically challenging or somewhat difficult problem. So what I did first here was go ahead and expand my left side, then add 4x over there. From there, I notice all my terms have x in common. It's equal to 0, right? Because that's how I solve for a solution is 97 equals 0. Expanded on out a bit here. So I took out my x. Now, moving on down, I want to factor this inside chunk here. So the first thing I did was I let u equal to the x squared. What that does is this makes it look like something I'm more used to factoring. From here, I could use a factoring method to arrive here, plug back in my x squared, and again, from solving through these terms a bit here, I will get to x is equal to 1 or 2. 17. We're trying to figure out the value of x. So this is just testing our ability to add and subtract, multiply, and divide fractions. So on the left, I combined my terms. They already had a like denominator of 9, so I got 3 over 9, x. On the right side, I need to acquire a common denominator. Well, I know 4 can multiply to 12, so I multiplied the top and bottom of 1/4 by 3. Now that I have a common denominator, I added on top, left my denominator the same. From here, I reduced 1/8 over 12, it's the same thing, 2 over 3, because they're both divisible by 4. That got me here. Then multiplying by the reciprocal. So again, we keep hearing that word reciprocal. So that's 2 over 3 times the reciprocal of 3 over 1 to get x is equal to 2. Which would be 2 times 3 is 6, divided by 3 times 1 is 3, so 6 divided by 3 gave me 2. Question 18. So, two isosceles triangles are shown above. They're told me one expression and y is equal to 75. What is the value of x? So the first thing I did is I took this first one, and I plugged in my y. What that did was allow me to solve for z. Now that I know what z is, right, so I'm over here. So I know that my x degrees, and whatever's next to it here, since they're on a line, are going to be, supplemented. I add to 180. Using what I know about isosceles triangles, I know that these two things are the same. So first, I took that 180 minus 30. I know it's equal to a plus a, or the sum of those other two angles of my isosceles triangle here on the right. Solving, I get a is 75. Then x plus a is 180. Plug in, you'll find out that x is 105. Moving on down here, we're asked to write an equation. So, at a lunch stand, each hamburger has 50 more calories than each order of fries. If 2 hamburgers and 3 orders of fries have a total of 1,700 calories, how many calories does a hamburger have? So my first one, I got my equation there, that 2 hamburgers and 3 fries is 1,700. And the next one I could get, I know that, well, a hamburger is 50 more than fries, so x is equal to y plus 50. So rather than using elimination here, since I already had an equation in terms of a single variable x, I just substituted. Distribute our 2, combine like terms, subtract the 100, I'll find that y is 320. So figuring back to that hamburger, I did 320 plus 50, and I got my final answer. Question 20. First thing I figured out is what I know about the problem. So B was my right angle, so I drew a triangle ABC. Doesn't matter what order we put it, as long as B is that right angle. I labeled that I knew BC was 16 and that AC was 20. So, just from the way that B is the right angle, I know this is my hypotenuse. So the first thing I did was I solved for AB. So, using our Pythagorean theorem here, I was able to find that AB is 12. From there, we can go ahead and move on in. So I know that similar means the sine of F is equal to the sine of C, because that's what they're saying. What is this? Sine of F, sine of C. So, moving on through, opposite over hypotenuse, well, that's 12 over 20, reducing, we'll find that 3 over 5. Moving on down here, this is our last and final section. So we have which of the following expressions is equal to 0 for all values of x. So choices B, C, and D do not work since absolute value will always be a positive number. So if I'm thinking here, absolute value always gives me a positive. There's no way I could take a positive and add 1 and get 0. So by default here, A is my only option. Question 2, we know that B is a constant. So what I did here was I substituted in that f of 6 is equal to 7. I found out what B is, and then I went ahead and plugged in that -2 to finally get my answer of -5. Question 3, we know that x, y is a solution to the system's equations above, and we're trying to figure out what y is. Well, first thing I did was I got y, or x I should say, in the first equation by itself. So I multiplied y on both sides. Then, from distributing my 4, I got 4y plus 4 is equal to. I went ahead and substituted my 6y here and solved for y. For this one, this just involves how we plug things in. So f of x is -2x plus 5. What is f of -3x? Well, we substitute that x for this term. Multiplying, there we go. Again, always substitute with parentheses. Well, which is equivalent to the above. So again, this just deals with multiplying out and combining our like terms. Again, we've talked about that a few times, so you could work through here with the workshop. Now we have this, which the following must be true. First thing I did was split this up a bit. So that gave me A over B minus B over B is 3 over 7. Well, B divided by B, that's just 1. From adding 1 to both sides. So first I made 1 as 7 over 7, because that's still 1 to get my common denominator. That got me to 10 over 7. I noticed that's about as simple as I'm going to get. I'm good to go. 7, this is getting back to, again, just determining what we know. So this involves finding the slope. And again, figuring out how things are increasing. So this goes back to like we talked about earlier, reading in context, figuring out what we need to find. So again, that there was like back to y equals mx plus b. I need to find the slope. Question 8. Parallel was our key word here. So when things are parallel, their slope has to be the same. So for each one of these, I isolated the slope. Parallel is exactly the same. And I checked, there's only one option. It was choice A that gave me a slope of -3. Here, we're told A is 2, so I plugged in 2, and again, we're just isolating our term here. As I move on, I found out there's 2 potential solutions, but I checked both. Only 6 work. So again, this is one, look through each step of work here, and you'll be able to follow your way through the logic. Question 10, we're told an equation, we're trying to figure out t. So first, multiplied by t minus 5 on both sides, distribute it. I'm trying to isolate my t. So I got all of it equal to 0. Add 55, divide it, and we got our answer. So for this one, again, a large variety of ways to solve this, but we're trying to think how many ordered pairs are solutions. So when we're trying to figure out how many, chances are we're going to work with what's called the discriminant. That's examining b squared minus 4ac and seeing what we get there. So what I did was I substituted my second equation into the first. So I got x is equal to, from expanding, distributing, all that wonderful stuff we love doing in math, I get to this equation. So examining my discriminant, well, a goes with x squared, b is with x, c is the constant term at the end. Here I find out that, well, I got a positive number plus, it's a negative times a negative, well, that's positive. I did 4 times 4 and got 16, kept that 49. And right there, if I'm doing a positive number plus a positive number, it's bigger than 0. So I can say there's 2 solutions. If you want the other parts of the discriminant, I would suggest Googling uses of the discriminant in quadratic equations, or again, just asking your local math teacher for those other possible solutions. For question 12, we knew that Paul's bill was $1 more than Ken, so I have the equations x is Ken and Paul's x plus 1. So the total here would be adding those two to get 2x plus 1. Figuring out a tip, right? So we're doing a 20% tip. So that means I'm multiplying by 1 plus that tip is a decimal. So that's where I got my 1.2. Multiplying by the equation that's representative of our total bill. And I'm splitting it, so I'm divided by 2. Multiplying out here, we arrive at our final equation. So again, being comfortable working with decimals is definitely a skill I would brush up on when preparing for the SAT. So, for this one, we got some complicated looking stuff, but seeing that they intersect here tells me something. It means that at these values, I have something that's equivalent. So no matter how ugly they are, the k is going to be the same here as it's going to be here. It's just going to be a positive and negative. So what I did was I went ahead and set these two equations equal. So that's going off the concept that 0 is equal to 0 because that's the corresponding y value in both coordinates. From working through, I have, again, adding 8x squared to both sides, adding 2 to both sides, dividing by 16, reducing 4 over 16 to 1 over 4, and taking the square root to get rid of my squared term, got me x is equal to positive or negative 1/2. So when you do a square root of a fraction, it's the square root of the top number divided by the square root of the bottom. And again, we always get that plus or minus. Figuring out what the value of k is, well, what that tells me is it's just going to be that positive version of 1/2. So we actually have both solutions, but again, we can think of k as a positive. Moving on to question 14. So here again, we've seen the same type of question above. So again, another thing to ask a local math teacher is, hey, can you write me a few problems like this, or can you give me some advice on these types of things? Now, I multiply by this, so I'm going to switch that to a plus because I know it's going to help me cancel out these middle terms and get that I out of my denominator. From doing that, you can follow the logic from the previous problem we did above with the same type of steps. The key idea here is substituting that I squared is really just negative. Now we're noticing a pattern. As we get really close to these non-multiple choice questions, the difficulty in the algebraic reasoning here and skills amps up a little bit. So, back to our good old quadratic formula. If you follow the steps through here, essentially what I did was take the equation. I subtracted 2p from both sides because I know p and k are really just constants. And then I identified my a, b, and c of our quadratic formula. I plugged in, and all I did here was just take my time and simplify. So getting it down to the most representative method here of what my choices were. So I broke it up as much as I needed to. Again, following the logic here. I know my handwriting isn't the best at this point, but again, if you want to work through these steps in a more in-depth explanation, this would be another question for your local math teacher. Moving on to question 16. So here we are in our last section of non-multiple choice for the No Calculator SAT. At this point, we are going to see the last bit of problems here and how we're going to go about solving them. For this question, first thing I'm going to see is I got some parallel lines. I'm told they're parallel, so I know they are. And what that means is I got a lot of similarity to work with here. So going off that given information we have. So the first thing I looked at was the ratios of what I called the medium triangle to the big triangle. Well, the medium is 3x plus 2x, so that's 5. And the big one, if I add all these coefficients, again, if we just have a variable and there's no number, the coefficient is 1, that's 6. Now, what I did to figure out this height was I did 5 over 6 times 18. Well, 5 times 18 is 90, divided by 6 gives me 15. Next, look at the ratios of small to medium. So now I'm trying to figure out what this height's going to be. So that gave me 2 over 5 by adding. Multiplying that by that 15, because now that's this height here I labeled. That gave me 6 inches. So that's the height of the top shelf. That's just right here. Subtracting those two told me that this final height, the height of that shampoo bottle, was 9 inches. Looking at 17, we're told what x is. We know where it's at, and we know where y is at. So we're trying to figure out the cosine of y. So first thing I did, I know it's 0.6. Well, 0.6 is just a fraction 3 over 5. So from labeling sine opposite over hypotenuse, I got to that point. If I'm looking at the cosine of y, well, that's adjacent over hypotenuse. So again, I found out that the cosine of y is 3 over 5. Moving on to 18. And again, if you want more logic on that, I believe it was in the first section we did a similar version of this problem. For 18, for what real value, so I want nothing involving an I here, that's what a real number is the equations above true. So, first thing we did here was I factored out that x squared term because I noticed these hadn't counted. So this gets back to group factoring. So I took out my x squared. Here I took out a 2. I notice these are the same. So group factoring tells me I can rewrite this as x squared plus 2 times x minus 5. Well, the 0 is there. If I solve this chunk of it, I'd get plus or minus 2i, or plus or minus I root 2. Well, that's not a real answer. But here, if I have to get a solution, which was true, if I plugged in 5, well, that will give me 0, 0 times anything is still 0. So that's my real answer there. So again, we got a system of equations, so I'm going to utilize that method of elimination. And here we're looking for the value of x. So we're going to go on through here. I just eliminated these x's up front, even though I want to get there at the end because I see that that was the quickest method of using elimination. Again, for a more in-depth method use of how we go through elimination, see earlier in the video for a better explanation, or again, Google, YouTube, local math teacher. So you can follow the steps through here to finally get our value of x. For question 20, we have the mesosphere. Ask your science teacher. In the layer of Earth's atmosphere between 50 kilometers and 85 kilometers above their surface. So it's telling us where something is. At a distance of 50 kilometers from Earth's surface, the temperature in the mesosphere is negative 5 degrees Celsius. And at a distance of 80 kilometers from Earth's surface, the temperature in the mesosphere is negative 80 degrees Celsius. For every additional 10 kilometers from the Earth's surface, the temperature in the mesosphere decreases by k degrees Celsius, where k is a constant, so it's just a number. What is the value of k? So as we can see here, I took that negative 80 and subtracted negative 5. Those are my points here. So what that's telling me is I'm looking for the slope. Here I subtracted the distance, or how far they were. So that was 80 minus 50. That's coming from up here. So we're looking at that 80 and that 50. They gave me ordered pairs. They gave me a distance, and they told me the associated degrees Celsius. That gets me here, reducing. That gave me negative 2.5 over 1. And multiplying by that 10 we found up here, for that every additional 10, I find out that my k is 25. I hope this was useful to you guys, and I really hope all of us do well when we take our SAT. And again, your best resource is going to be talking to your local math teacher, utilizing Google, utilizing YouTube, because there's a lot of great stuff out there. I would suggest taking a little bit of time each day over your spring break, whether you're working, participating in a sport or activity, or just looking to relax with some friends and family. Take a little bit of time each day and do a few of these problems. That's going to help it resonate with you. It's do not cram for the SAT. You guys are going to do great. I know it, and best of luck. Again, this is Mr. Ciolkosz, better known as Mr. C, doing what I can to help you guys do well on this standardized test, the SAT No Calculator section for math.